In this video, we'll be dividing complex numbers using a lot of what we've been learning recently. Let's start by reviewing the standard form of a complex number. We are asked to write this number in standard form of a plus bi, where a is the real part and b is the imaginary part. The reason why this is an imaginary number or a complex number is because we have a negative number under the radical. So we're going to rewrite the radical as some perfect square times the rest of the stuff. So 25 is a perfect square. What's left over is negative 1. I can take the square root of 25 out of the radical. What's left in the radical is negative 1, the square root of negative 1 being I. So my answer here is 2 minus 5i. This is just a review of writing things in standard form. The next example, writing in standard form. The first number is not in standard form because I need a real part and an imaginary part. But I squared is negative 1. So now I can just rewrite my order as my real plus my imaginary part. So put the real number first, the imaginary number second, and that's my answer. The number 8 is not really a complex number. If you want to write it as a complex number, we need an imaginary part, 8 being the real part. So let's do 8 plus 0i. The next number, this is going to be an imaginary number because we can think of negative 49 as the square root of 7 times negative 1. Now I can recognize that as 7i, but I need a real part, so I can add a 0. 0 plus 7i. Okay, now that we've reviewed that, let's move on to dividing complex numbers. The first example will be the simplest. I have just a monomial here, 6 divided by I. Now I'm not allowed to have I in the denominator. So I want to get around that by multiplying by a disguised form of the number 1. I will multiply 6 over I by I over I. The reason for that is that we remember I squared is going to be negative 1. So now I can just divide my 6 and my negative 1. I get negative 6i. To write this as a pure or a true complex number, I want a real part, so I get 0 minus 6i. That's my answer. So that might be the simplest type of example that you'll have. Now let's move on to another type of example where there's a single monomial here in the numerator, but a complex number in the denominator. And I want my answer to look like this. I'm not allowed to have I in the denominator. So let's multiply the denominator. Let's think about the conjugate of 4 minus 5i. So we'll multiply this fraction by 4 plus 5i over 4 plus 5i. Now the numerator is just going to be 4 times that binomial of 4 plus 5i. The denominator is really the difference of perfect squares, right? A minus bi times a plus bi. We've done this style problem a lot. It's going to be a squared minus b squared. So a squared being 16, and then negative 5i times positive 5i is negative 25i squared. Now distribute the 4 in the numerator, and in the denominator, let's rewrite it as I squared being negative 1. Now let's simplify our denominator. Negative 25 times negative 1 is positive 25. I can simplify that further by adding 16 and 25. And now I want to break this apart to be a complex number into a real part plus an imaginary part. And I'm simply using the denominator and breaking this into two kind of fractional components. This is my answer because neither fraction can be simplified. So I have divided 4 by 4 minus 5i, and this is my quotient. All right, last example is the more complicated one. We have a complex number divided by another complex number. We want our answer to look like this. Let's start by multiplying by the conjugate of 1 minus 2i. And we're multiplying, of course, by a disguised form of the number 1. Now my denominator I can handle in my head because it's just going to be a squared minus b squared. So 1 minus 4i squared. My numerator, you could go ahead and write this out as a box. I typically like to think of these with FOIL, and because it's always going to be a binomial times a binomial. So I do f, first 2 is 3 times 1, which is 3. Outside 2, inside 2, and then last 2. And I write it out just like that as 4 terms, F-O-I-L. First, outside, inside, and last. Now I can simplify this. In my denominator, I end up with 1 plus 4, because of course I squared is negative 1. My numerator, the 8 times I squared is negative 8. And the 6i plus 4i is 10i. Notice I'm writing this out in stages. I do not try to do all this at once because I'm less likely to make an error if I write it out in stages. So I have negative 5 plus 10i in my numerator. I have 5 in my denominator. Ultimately, we're going to end up with this answer, but where that came from, and again, I like to write it out in stages, is negative 5 over 5 plus 10 over 5i, which I can see will simplify to negative 1 plus 2i.